Welcome to the Ideal video series on frequently asked questions. This is a series of short videos to explain how to approach common scenarios, model specialized BMPs, or troubleshoot typical issues. Today's video is about how to appropriately model underground detention. Underground detention systems are becoming a common practice for urbanized areas when insufficient space is available on the developed site to manage stormwater runoff. Underground detention often includes subsurface infiltration, which can provide some water quality benefit. Therefore, it is important to model this system in Ideal. Treatment mechanisms in an underground detention system are similar to a typical dry detention pond, so you will model your underground system by using a dry detention pond BMP. The model inputs will differ from a typical dry pond though, so let's look at each input and discuss how to use this BMP for underground detention. The first Inputs tab is where the infiltration method is set. Does your system provide subsurface infiltration? If yes, the green and amped infiltration method should be used. The soil texture should match the underlying soil. The degree of saturation is a measure of how saturated the soil will be at the beginning of the storm. Because an underground detention system does not receive direct sunlight, it will tend to take longer to dry out between storms, so a higher degree of saturation should be used, such as 0.6. If your system does not provide subsurface infiltration, as would be the case if your system has an impervious bottom, then select the simple infiltration method and use an infiltration rate of 0.001 inches per hour. Ideal requires a non-zero infiltration input for ponds, so this minuscule infiltration rate will simulate an impervious bottom. Next, you'll provide inputs for the stage area table. Clicking on this blue information button will display a diagram of the pond stage area inputs. This table is an essential component of modeling an underground detention system, so you want to pay close attention to these inputs, especially the top and bottom areas. First, the bottom area. Ideal calculates infiltration based on the bottom area of the pond. If the underground detention system's bottom is impervious, then stage 0 will reference the bottom of the storage area. This diagram is an example of this scenario. If the underground detention system's bottom is a gravel bed above the subgrade, as shown in this diagram, then the void spaces in the gravel layers should be counted as volume. The bottom area should be modeled as the actual area. However, the actual height of the gravel should be multiplied by the void ratio of the gravel, and that calculated height should be used in the model to simulate the correct volume. The stages above the gravel layer will have to be adjusted based on the modeled gravel height. After you've modeled the bottom area and up to the top of the structure, the top stage needs to be considered. Ideal calculates rainfall on the BMP based on the top area of the BMP. Although the underground detention system will not physically receive direct rainfall, the amount of rainfall on the pond will still be calculated by Ideal. Because of this, you will need to simulate a closed-top system so that the rainfall on the pond is minimized. This can be accomplished by adding an additional stage area row just above the actual top stage of the structure. Make this stage 0.01 feet above the top stage of the pond and give it a minuscule area of 0.0001 acres. For example, using the auto-populated values already here in the table, if the stage at the top of the pond is 2 feet, then I would add a new stage at 2.01 feet with a corresponding area of 0.0001 acres. The intention here is to close off the top to rainfall without adding or reducing volume to the detention area. It is important to note that Ideal interpolates areas between the entered stages, so the additional stage and area should be added on top of the design system rather than just replacing the area of the top stage. Let's do an example together of filling in the stage area table using this diagram. Remember, stage 0 represents the top of the subgrade soil. In this scenario, the 1 foot of gravel multiplied by a void ratio of 0.4 makes the stage of the top of the gravel layer 0.4 feet. Then, we need to adjust each subsequent stage input based on the 0.4 feet modeled height of the gravel. Now we need to close off the top of the structure by adding an additional stage and area, just like we discussed earlier in this video. The stage area table for this example is complete. The remaining inputs for the riser and the emergency spillway are filled in the same way as a typical dry pond. The heights of the inputs should be referenced from the top of the subgrade. To model underground detention with a forebay chamber, the same modeling process is utilized in conjunction with a separate dry detention pond BMP to simulate the forebay. The chamber should be modeled as a separate BMP if the flow is infiltrating. See the Ideal Frequently Asked Questions video number 8 for details on how to model a forebay in Ideal. If the underground detention system includes a section treated by running through filter fabric, hydrodynamic separation, or another manufactured treatment system, then a separate user-defined BMP should be used upstream of the dry detention pond object. The user-defined BMP will be representative of the manufactured treatment section, and the dry detention pond will represent the remaining area of the detention system. See the Ideal Frequently Asked Questions video number 4 for details on how to use the user-defined BMP object. To summarize, pay close attention to the following sensitive variables when modeling underground detention in Ideal. Remember to properly account for infiltration into the subgrade on the first tab, account for any void storage in a gravel underlayer, and close the top of the system in the Stage Area tab, and model your outlet conditions using the Riser, Orifice, and Emergency Spillway tabs. Thank you for using Ideal. As always, if you have any questions about Ideal, please contact the StormOps support team at info@stormopssoftware.com. Also, visit our website and follow us on LinkedIn to get the latest news on support and new releases.